Hello students, welcome to AskPrep. Today we'll be starting with exercise 1.4 of grade 11 mathematics CBSE. Now before we begin with our exercise, let us see what all concepts are we going to learn today. Today we are going to learn about Venn diagrams, we are going to learn about operations on sets and also about the difference of sets. Okay, so first let's get started with Venn diagrams and understand what exactly are these Venn diagrams. Now, when I talk about Venn diagrams, these Venn diagrams gives me the relationship between the sets. It could be relationship between a universal set, a subset, and few more 2 to 3 more sets, or a relation between a superset and a subset. Also, Venn diagrams help us on performing operation on sets. Okay, now what operations, which we'll see further. Now, why do we need these Venn diagrams? Now, Venn diagrams is basically pictorial representation of sets. We can represent them pictorially. But why do we exactly need these Venn diagrams? Now, if you compare with the example of your graphs, okay, especially when we talk about bar graphs, when I have data in the form of a table, it is little difficult to interpret the data. But whereas I have the same data in the form of graph, it becomes easier to understand. It is easily readable, and also I can interpret it easily. It's the same case here. Venn diagrams make our work a little more easier and make it easier for us to understand the representation of sets. Now, usually Venn diagrams comprise of rectangles and circles. Now, what exactly is a rectangle? My universal set is represented by a rectangle. Now, so that means what I have drawn here is a rectangle, and this is my universal sets. And all my sets are contained in this universal set. Now, let me draw another set A here. Okay. Now, let us write down the elements of universal set. The elements of universal sets are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Now, what do we see? We see that set A is contained in my universal set. So that means A is a subset of U. Yes or no? Now, let us draw another set and see another example of this relationship between my sets. Now, again, I am drawing a rectangle. That means this will be my universal set U. Now, let me draw a set A inside this universal set. Okay. Now, I am drawing further one more set. Let this set be B. Now, let me write down the elements of this universal set as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Now, what do we see? We see that element B is contained in set B is contained in set A. Again, set A is contained in universal set. That means B is a subset of A, and as A is present in my universal set, that means A is a subset of my universal set U. I hope now we have understood as to how we can, understand the relationship between different sets. Now, let's move on to the next concept of operations on sets. Now, what operations are we going to talk about? Let us see. Are we going to add, multiply, or divide sets? Let us see in detail as to what operations are we going to do on sets. Okay. Now, the first operation that we would be talking about would be my union of sets. Union of sets. Now, what do you mean by this union? Now, let me take an example and explain it through this example. Suppose I have my set A containing elements 1, 2, and 3, and I have another set B containing elements 2, 4, and 6. Now, when I talk about union of sets, union of set contains all the elements of set A and set B. Now, when I'm talking about, what did I say? Now, when I'm talking about the union of sets, it consists of all the elements of A and all the elements of B, but without repetition of elements. Now, how is this union represented by? This union is represented by the symbol. Okay. And now, how do I represent it when I'm dealing it with sets? Now I will write it as A union B. That means I'm talking about the union of sets A and B. Now A union B, as I said, will contain all the elements of A and all the elements of B. Now let us see what are the elements of A. First, let us write down the elements of A. They are 1, 2, 3. Now let us move on to the elements of B. Now 2, but we already have element 2 that was a part of A, so I will not be repeating this. Moving on to the next element, 4 and 6. This is how I will write union of elements. Now I hope that is clear. Now let's just take another example. Okay, now let me have a set A that contains the vowels of my English alphabets, and they are A, E, I, O, U. Now let me have another set B that contains I and U. Okay, now I want to find out what is the union of these two sets A and B. So I will write it as A union B. But before that, pay attention to the elements of set A and set B. What do we see? We see that whatever elements are present in B, that is my I and U, are already present in my set A. So now what is the relation between my set B and set A? Here I can say that set B is a subset of A because it contains all the elements of A. So now my A has become a superset and my B has become a subset. Okay. Now let's move ahead. We were talking about A union B. So let us see what will be the A union B of a superset and a subset. Now let me write down the elements of set A first. They are A, E, I, O, U. As we have already seen, B is a subset of A. That means the elements are already contained in my set A. So I will not have to write those elements again. So now this is my A union B. Now what do we see? A union B is nothing but the set A itself. Yes or no? So what did we notice now? If we are doing a union of a superset and the subset, the union will give the answer as my superset itself. So A union B would be A itself when B is a subset of A. Now let us see how do we represent this A union B using my set builder form. Now A union B in set builder form is written as the set of all x such that, now what do you think? X belongs to A or X belongs to B. So X either has to be an element of A or it has to be an element of B. Either of these two, yes? Then only I will have my A union B. Now, let us understand this pictorially as to how are we going to represent A union B in the form of Venn diagrams. Now, this is how I represent my A union B. My A is also shaded, my B is also shaded. That means I will take in all the elements of A and all the elements of B, and that would be my A union B. Okay. Now, moving on to the properties of operation of union. Now, let us see what are the properties that we have when we are performing the operation of union. Now, I think we have discussed most of these properties in integers and when we have learned about rational numbers and all in your previous classes. Now, let us apply the same properties here. Now, my first property would be commutative property. Now, as I'm talking about union, I'm talking of union of A and B. Now, what is my commutative property? Though I interchange the positions, the union or the solution will still be the same. Either I do it as A union B or B union A. It will contains all the elements of A and B irrespectively. Yes. Now let's move on to the second property, that is the associative law. Now here we will be having a union of three sets, that is brackets A union B of union C. Now again, I have three sets here. So the union would be the elements of all the three sets. So it doesn't matter as to I can do the union in whichever way I want. Either I can use A union B first and then do union C, or I can do B union C and then do union A. The answer will still be the same. Now let's go for the third property, that is A union phi. Now I hope you remember what is this phi. Phi is a null set. Now this is called as law of identity element. Now, here phi is my identity element. Now, when I am doing a union of set A and a null set, what will be the final union of those two sets? Null set doesn't contain anything. So, obviously, my answer would be set A itself. I hope this is clear. Now, moving on to the fourth property, that is called as idempotent law. What is it? Idempotent law. Now, I am doing the union of A with itself. It already has the same elements. So obviously my answer would be the set A itself. Now, fifth and the last property would be union of universal set and set A. Now, this is called as law of U. Now, universal set contains all the elements. Set A contains only few elements, excuse me. So what do you think would be the union? Obviously, the superset, which is my universal set here. So union of universal set and set A would give me my universal set itself. Now, we will move on to the intersection of sets.